All right, there's 3 different methods to graph. Okay, we're going to use this polar grid, and y'all assume kind of use the concentric circles already to graph. You don't really have to, but that's just a way of saying, okay, if I go out 1, I'm going out this way, this way. You can totally pretend that there's concentric circles. You don't have to draw them in if that annoys you. Okay, we don't want to be annoying on our homework. Okay, so of course we talked about a polar equation. The variables are polar coordinates. Here's what we don't have to do. Number 1 is typically most of us would say, let's just switch that back to rectangular coordinates. I'm really good with graphing rectangular equations, so I'm good. Okay, you'll have circles. Okay, you'll have lines. You'll have hyperbolas, but not a lot of those. You could have parabolas as well. All of that ever came up, but then you'll also have more interesting things also coming up than those few things. Okay. Number 2, let's say we don't want to take that trouble. We could just that is sorry. That's number 2 that I was talking about. Switching it over, and let's just do what we're comfortable with. Okay. This is the process that we're going to do next class. Okay. Which is pretty tedious, but it's good because it makes you, oh, that's how that works. Okay. We'll do it in class. You'll do it one more time on the project, and we're good. It's very tedious, so we're not going to have to do it on a tech quiz. No, it's just you'll do it on the project one time. All right, and then the other one, of course, we did last class is graphing using the calculator. Remember, we have to have mode being in polar mode, and make sure we're in radians also. Okay. All right, so we got 3 methods. First, we're going to start with converting to rectangular coordinates. All right, so you should be good because that's what Emma did up here. Or, well, Catherine did the other direction, but that would be starting here and going here. So we're going to convert to rectangular coordinates. Okay, r equals 3. R equals 3, well, we have 2 methods. Multiply by r or square both sides. That's about all that we were really doing. There's going to be other few things that come up. Which one works here? Square. Okay. So r squared equals 9. All right. Now what do we do with r squared, Sydney? Nice. Okay. And then, of course, we should recognize that because that's the standard form for anybody that's had Algebra 2. Okay. Now, you know, y'all are the cut above most Algebra 2 students. You asked a lot of Algebra 2 students, they were like, what? Oh, Hannah, tell me what that is. So that's a circle, not or, a circle. And what do you know about that circle? The radius is 3, and check that out. Okay? All right, and I wasn't telling her that was done for her, but had we thought about it, whoops, we would have just like done that, and we can later. And what else do I know about that? Center, maybe? Yes. Is good job. Okay. And then we can graph it. Let's say graph, right? 0, 0, center, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. There we go. There's graph. Okay? Now, if you recognize r equals 3, if you think about it, well, of course, if the radius is just 3, it's going to be a circle. It's not going to be any tricky anything else. Okay? So, embedded here in the notes are some things that you're like, okay, I know that one, the polar. Just like eventually you got to understand, wait, I know what this is. Okay, what is that, Greg? Parabola. okay? You're going to be very comfortable graphing that in calculus, okay? Wait, I know what this is. Okay, so you're going to get to that point. We'll only have 2 sections to go there, so it's not going to be that comfortable that you're going to say, oh, that's that. You're going to have to think about it. You're going to have to spend some time memorizing, oh, wait, how do I tell that from that deal? But that's our goal, is to memorize some of the standard equations, okay? All right, so let's try r equals 2 sine theta. All right, do we want to square both sides, or do we want to multiply by r? Multiply by r. So r squared equals what, Lindsay? Good. Now, what are we going to do with that, Megan Cook? Good job. Remember, sine is y, cosine is x. That's our sine. Okay. Now, in order to graph that, we're going to have to, do you know what it is right now? You should. Because of the x squared plus the y squared, the coefficients are the same of x squared and y squared. That's circled. If they were different, it'd be an ellipse. You could go either way, where you're going to kind of stretch it out. Okay, so we're going to bring that y on over, leave a space, and whatever we do to the one side, we're going to do the other. So go ahead and complete that square. Great. All right. Final form. Natalie Revers, you there? Okay, what do you got? Can you fill in this bottom line for me? I don't know, is it? I'm asking you. This is X. So you're not there, or? Okay, I'll wait for you then. Sorry, I thought you said you were there. It's to the end there. Quit asking me, tell me what it is, girl. All right, and all right, very good. So she completed the square. She took half. This is this. Okay. This now becomes this. Took half of 2, squared it, and added it to both sides. Okay. So what do we know about this? The radius is what, Lizzie? 1. Because radius squared is 1. All right, and the center of this circle, we already said it was a circle a while ago. Kathleen, what's the center? 0, 0. Were you thinking about 1 or negative 1? Okay, it is 1. Remember, the standard is S. Okay? If that is the standard, then if that stays at 1, then K must be 1. K is HK, the center. Okay? All right, so then we graph it. Let's see. Center, 0, 1, right there. Okay? I'm going to go, and I'm going to be sitting right on my axis there. Okay, because I'm going to go 0, 1, up 1, over 1. Okay, so it should be tangent to the x-axis. Remember that word? I've used that word in a while. That's a big word in calculus. Okay, any questions on that? All right, let's try that one. This has a different technique. I'm thinking that I'm going to give you time to see if you can come up with it, because I know you're very smart. But the 2 methods that we talked about last class, I think this would be very helpful. You got a graph there. Okay, are you converting to? Okay. That might help. Do something. Yeah, we're converting. Some of you have part of a graph. I don't know if I've seen the whole. Oh yeah, there it is. Anna's got the whole graph going here. That's half of it. Let me show you what Hannah's got here. Where is she? And let's view her thing here, maybe. No.
Other view. Other view.
You went to the right.
There you go.
You were like, maybe I'm going left. There's the graph. And she came up with, wow, you're even better than I thought you were, Hannah. X equal Y. Okay. That doesn't sound right, does it? It's sort of like saying, never mind, because that would be even worse. Okay, so tell me your chain of events here. Train of thought, I guess. Okay.
And I was like, well, what are to be negative? Okay, that's the other way. And then I was like, okay, well, if I start thinking about it like rectangular ways, and I have, well, the origin is 0, 0. So I just kind of did mx, y equals, or, well, I sort of did y equals mx plus b. But I was like, okay, well, the slope is just, since 45 is just 1 over 1. And then it intersects at 0, so, well, they're equal to each other.
It's brilliant, right? Okay, brilliant. So that is, that's one way to get there. Let me stop viewing here, Hannah. And another method that you might consider is, remember our toolbox. All the toolbox that we've used so far involving something was this guy, this guy. Okay, what was that other one? Okay, so could you make that happen? If I make this to tangent theta, what would I do to the other side? What you do unto one side, you must do unto the other. Remember the golden rule or the first commandment of math or whatever? Okay, that's true story. All right. First commandment, that's right. Do unto one side as you do unto the other. All right, tangent of pi over 4, what is that? 1. Okay. So tangent of theta is, y over x. Okay. And then there's Hannah's white flags. Okay. So, you know, if your goal was just to graph it, some of you have the graph, but remember what she said, wait, R could be negative, so that brings us the other half. And if that's what you were doing, you're done. You didn't have to do all that. But if you wanted to change to rectangular, convert, and graph, you would have to come up with a y equals x as well. Okay. Very impressive, Miss Hannah. Okay. Did anybody else come up with y equals x? Woo. All right. Let's try our converting still and identifying. Anybody have a guess what it is right now? Y equals -3, okay. That's a straight line. All lines are straight, just FYI. Horizontal line, where would it be? At -3, very good. Okay? I know. Everybody says straight line. when they mean horizontal line, but it's not really what you meant. So we got to say what we mean, right? Very good, though. All right. Now, let's get our calculators out. Okay? Change up your mode. If you've been back to degrees since you've been correcting your test, you're probably back to degrees, radian, and go back to polar mode. So I'm back in radian mode, and not function mode, but polar mode. Okay? So that's the mode I need to be in. Function, not function, and those are the big things. Okay, the window is very important too. So let's go ahead and set that up because it's not just like you're going to cut off your circle deal. It's like a major difference if your viewing window is different. Okay. So what we want to do is we want to make sure our window, just press window, is set up to, let's go to 0 to 4 pi. And I already put that in, 0 to 4 pi. And your calculator will change it to a decimal, don't worry about that. And then that is pi over 12. And that's where typically your polar paper, your polar graph paper is. So 0 minimum, theta minus. Okay, 0, 4 pi, pi over 12. Now, this you can mess with the x minimum, you don't want 0. You want a square. See, when you look at this graph, I don't know if I have anything in here. Oh, wow. Okay, that was that thing left over from yesterday with a different window. But remember my equation from yesterday was at 4 sine 10 theta, and then I changed my window since then. So that's what it looks like. What you want to do, this right now is rectangular, major rectangular. Let me just clear that up. And you can't, what am I doing? Clear, clear, clear. Okay, when you look at the graph, what you want to make happen is that this increment is about the same as this. That's what makes it square. Because this viewing thing is not square, it's rectangular. So if you have 10 to 10, 10 to negative 10 on both, it's not going to be a square. So go back to your window and let's do your x. You have a bigger space. So let's do negative 15 to 15 in terms scale of 1. And for 10, let's make it just from negative 10 to 10. It's going to be pretty close to square. Okay? If you look at the increments, they're pretty close to negative 15 to 15. Okay? So now, every time you switch back to rectangular mode and switch your window up, you're going to have to switch it back. Where is it? This 0 to 4 pi, it is like amazing how much difference that makes in some graphs. Okay, so if we're going to graph using our calculator, we have to solve for r, just like with our calculator, we have to solve for y rectangularly. So what does r equal? Negative 3 over sine theta. Okay, so we put that in. Negative 3, you can use the nice fraction or not. Remember, the theta is found where the x used to be. We talked about that last class. Okay, graph, that was the one we just did, but we converted it. Okay, now, so that's very easy to do. Graph, done. Okay. Let's try next one. R cosine theta equals 2. Okay? Clear that one out. Have to solve for R. R, we're going to put in our calculator. We're going to put in Jillian. Okay. So our calculator, 2 over cosine theta. Theta's the same place where x is. Quit saying that. I got it. Of course, it's going to be a vertical line this time, right? Okay. All right. So a square or rectangle wouldn't have mattered on those. Oh, yikes. Okay. All right. So we've got a theorem here. This is where we start looking at, oh, wait, this is always going to look like this. I don't know, but about you, but I like to have things on one page and I have to look at 50 different pages to find it. So this is kind of an organization. You can fill this in as you get. These are different curves that you're going to have. You're welcome. You got your line, of course, your circle, your rows, meniscus, and limacon or limacon, depending on how you want to pronounce that, cardioid, and the spiral. So those are all the ones we're going to talk about today. He doesn't recognize those words. That's why they're squiggly lines, but they are definitely words. Well, I snipped it. Okay. So this is and here's the thing. You are going to have to know one from the other. You're like, they're all the same. They're not going to be all the same. That's why you're going to see that on that organizer. Okay. If you have this, r sine of theta, remember r sine of theta is y, so y equals a is going to be a horizontal line. Okay? So on your page, under line, put maybe r sine theta equals a, or r cosine theta equals a. Okay? Now, I'm not going to expect you to remember that if it's if a, let's see, if a is less than 0, it's going to be to the left. If a is right, you know, I'm not going to expect you to remember all those little details because you're not going to have time to develop all that deep knowledge. But I would expect you to recognize that that's a line equation. Now, if you can't, then you have to convert it, and then you're like, oh, okay, it's a line. Okay? So those are your lines. All right? Remember, there was also another line that came up today. Where was that? This line. So you might want to also put in there that just theta equals some letter. Okay. All right. A, yeah. A would work. What's the matter, Megan? A is some. Right, but if theta equals pi over 3, it's another line. It's just not y equals x line. Good question, though. Okay, identify and graph the equation r equals -3 sine theta. Okay, so is that a line? Okay, because it looks like r sine theta, where a, no, it really doesn't. Okay, well then. Okay, let's graph it. That's what we're doing. Clear, -3 sine of theta. This is why I'm saying they all just start looking the same. Well, yeah, they all have thetas and r's in them. So do rectangular coordinates have x's and y's. So you could say the same thing about that, and you can tell the difference there. So that one is not a line. It's a circle. Okay? So there's your graph. Your graph is a circle. Okay, what do we know about that circle? We know it's kind of tiny. We go back to single page here. All right. What do we know about that circle? We should be able to identify the center. And the radius from the graph. What's the radius? It looks like it. Those are all in ones, remember? Can I zoom? Sure, but that's gonna change my window, but it won't zoom in, right? All right. Okay. Three is the diameter. So 1.5. Okay. And I think you can see that. Remember, our scale was 1, so you should have been able to count 1, 2, 3. Take half of that to get radius. Okay. And then what's the center? 0, negative 1.5. Okay, good job. All right. So if you're identifying the graph, you need to give it some, just like we don't want to just assume all lines are Pythagorean. No, they're not. Okay. So they have specific slopes, intercepts, whatever you seem to be talking about. Yes, please. I don't care. I do not care. All right. Identifying graph the equation of r equals 4 cosine theta. All right. I'm going to go back to zooming out. So I'm back to my original thing. And let me put that back in here. I'll put it in here. For cosine theta is going to be another circle, isn't it? Okay. So it's a circle. What do we know about this circle? Radius is 2. Because if we go 1, 2, 3, 4, there's your radius squared. Was the same thing here. Radius squared, I count the negative piece, of course. Okay? And then it's sitting on the x-axis, thus cosine, as opposed to sitting on the y-axis. I have the sine up here.
Wait, is it radius squared and how like 1.5?
It's not radius squared, sorry, I lied. All right. Yeah. And then what's my center? 2, 0. Okay. All right. I think the next page says, oh, okay. Well, here's what your surface could possibly look like. And you all have already picked up on that because I made a mistake on your letter back there. That's 2A. Okay. Honestly, I wouldn't write that twice. I just put plus or minus. Plus or minus. Okay, A, or you could just put A could be plus or minus. But if you're on the sine theta, you're going to be sitting on the y-axis. You're on the cosine theta, you're going to be sitting on x, which makes sense. Each circle that we know of on this passes through the pole, which is the origin, remember. Okay? All right, so you got lines, you got circles. Didn't we also have another type of circle come up? Like, wasn't just like r equals 3, wasn't that a circle? Okay, so you might throw that in there too. Just, it's just an organization. You can just choose to, you're going to have to remember how you're going to have to remember it, but, and some of those are easy to, oh yeah, that makes sense. So it's not really a memory game there. Okay. I don't know what that is. I meant to get rid of it. Did I get rid of it yours? Yeah. Yes. Okay. Graph the equation r equals 1 plus cosine theta. Okay. Here we go. This is where we start the fun ones. This is going to be the cardioid. Any heart doctors back there? Megan? Did you have a doctor, family member? Yeah. A cardiologist? No. Okay. All right. Now, you can't see it. I'm going to zoom it in. Did I?
Yeah, you just
Oh, well, just go to here. I don't think there's symmetry on that. I think that's what it is. Yeah. I don't want to just get rid of it.
You don't need it.
No. Okay, because it's like, it's not really that helpful. So I just kind of decided, I guess I worked on my copy, not on yours. Okay, so go to this page, which is the cardioid, and we have, supposed to look like a heart. What's the name of the cardioid? Okay, some people say it looks like a butt. Okay, so anyway, that's a cardioid. Yes, you need to know the names. Okay, but it's almost a circle, but it dips at some point. Okay, let's see. We got A on the outside. Okay, and we've got 1 plus cosine theta or 1 minus cosine or sine. So somebody give me another example of a cardioid. And you don't have to leave the A outside there. You can kind of distribute it. So this is A plus, here's how I would write that, honestly, plus or minus cosine theta, R equals A plus or minus sine theta. A, sorry. Okay, key is that A has to be the same. So who's going to give me an example of a different cardioid other than the 1 plus 1 cosine theta? That's the one we just have in there. Give me another one. Emma.
4 minus.
All right, 4 minus 4 sine theta. Okay, 4 minus 4 sine theta. I might have to go back. Minus sine theta. Oh, shoot, I missed the 4, didn't I? Okay, I did it on my own PC. I tried to do that, and I was like, okay, I'm going to have to zoom back out. All right.
I try to touch my computer until that's not touching.
I do all the time, yeah. What's happening here?
I don't know. Yours is chill.
I'm going back. No, that's not. Well, you should have a square. You shouldn't have a. Oh, for gosh sakes. What did I do wrong now? 8:15. Wait. Okay. Slow down. 1. Okay, so you've already figured out some things that you can totally distort that cardioid, right? By not having a square thing. You can make it look more like a heart if you distort it. But typically it's supposed to be sort of roundish. So give me your, somebody, I heard a wow. What, somebody tell me their window that they ended up with having some kind of wow factor here. Come on, Molly, it was you, wasn't it? It was Cat. Oh, okay, good. All right, well, very good. Okay, so what did you add? That was beautiful. You just kept adding them here and then, okay. Okay, so tell me what you added. Okay. Okay. 2 plus 2. So you just kept adding them. Yes. So that's exactly, she's already knows exactly what we're going to do for our project. We're just going to start throwing things in there and see what happens. Okay. Whoa. That's a little big.
Mine says it here.
You put
I made a little
I know.
so pretty.
Yeah, that's unfortunate. You got your, see that? You got your stack plot on the that. I know, see that plot 1 was highlighted, which means whatever was in here, it's trying to plot. And you can't plot it because
it's not set up, your window's not set up for that. So you don't want any of those to ever be, unless you're actually doing a stepwise, ever be highlighted. Okay, it should work now. What's going on?
You have color, I just did black and white.
Yeah, the color one's a way better.
Oh my gosh, there's it's cute color. Whoa, you can change, I'm changing now.
Okay, I know which one. There's a minus sign was for
If
me.
you add neighbors, it's from. Like it would be like 4 plus.
Oh, that's my fault.
Can't use the minus sign, or the negative
So I'm
sign.
gonna do navy yellow.
Yeah.
Plus navy, I just can't do It's like this. No, ours out here, A got distributed. Yeah, because that's gonna be a big distinction. All right, so just to be clear, A got distributed, so these two numbers have to be the same. Not the same sign, but they have to be the same. Okay, so let's clear out what we got out here. You all are making me excited about what you're gonna show me. But yeah, it's kind of laying them little sticks. Anybody ever mess with Desmond's scrapping? Okay, there's an online thing that will work on that you can do more than 6, and then you can be more creative. Okay, switch it so that A and A are not the same. Well, duh, they're not A and A anymore. So 2 plus 3 cosine theta. You already did that? Okay, just look at 1. And then you got the next 2 pages. Okay? You've got, yeah, I always forget how to pronounce this. So I did a link to dictionary.com. Because it's supposed to be limicine. My Midwest wants to say limicine, but it is limicine. Okay. Check out the differences between these next 2 pages. We've got, watch, girls. Got it. Did you add those, the cardioid equations on there, on your green sheet? Okay. All right, next is limicine. We've got 2 of them. We got one with an inner loop. We got one without. Now, I just threw something in here. Do you see this is with a loop? You see the little loopy-doop in there? Yes? No? Maybe? What was my equation? 2 plus 3. What's the difference between, and did I do sine or cosine? Cosine. Okay. What's the difference between if you want to end up with a loop or not a loop? The first number is bigger or the first number is smaller. Okay? So you're going to have to remember the difference. All right, let's start with this one since we already did. We're on example 11. We're coming back to 10. Okay. 1 plus 3 sine theta looks like 1 plus 3 sine of theta. It should be a limicine with a loop. That's a more substantial loop here. Okay? So I'm guessing, and you can play around with them a little bit if you're really interested, the difference between these two, if it's bigger, your loop is probably going to be more significant. This loop, remember, was pretty small. But 2 and 3, there's not much difference, so it's almost like a cardioid. Yep, that's cool. All right. Okay. Then we have a limicine without an inner loop. Remember, we can do cosine, we can do sine. Okay? So 3, and these, honestly, are very hard to tell the difference between cardioids. I think they look a lot like cardioids to me. 3 plus 2 cosine theta. Oh, what the heck? Cosine theta. Okay? Do they look like cardioids to me? So here's what you're going to do. Add your limousin in there. Okay? You're going to have to recognize without a calculator what that is, just by the looks of it. Or, I'm not going to tell you the difference between a limousin and a cardioid because I don't think you can tell the difference. That looks like a cardioid to me if you don't have the loop inside. And I'll have a graph and you'll say, okay, that's a, okay. So there's some vocabulary, okay, that you're going to have to learn, and you're going to have to learn the, remember, you know, this business. Either A is bigger than B, it's a, or A is smaller than B, it's a, okay? All right, so moving right along, we got rows. We even have a, for you here, why you mess with your rows. First, we have a little commercial. Don't cry now. Yep, that's the rows. That one's not very pretty. So, so how will you change that again? Okay. Oh, that Emma, she doesn't miss a lick. She said, remember before the data how many petals you're going to see? Well, let's try it. Let's change 5 to 6. It's totally related. Yeah. Good call, girl. What does the 4 do? Yeah. What does the 4 do? Change like 4, see what happens. I'm going to change it bigger. How big it is? That's ugly. That's not ugly. It looks like a firework. Oh, okay. All right, then. It's not a flower. Can you do cosine? Yes, you can do cosine. But, you know, look at this. Okay, wait a minute. Let me write this down. Sine 6 theta. Go ahead. 3 sine 4 theta. 3 sine 4 theta.
Yeah, but then if you do 3 cosine 4 theta, do both.
Do both? Okay.
I don't like this one.
I love it.
Wow.
Those are flat on the top.
Those are pointy.
I know.
I like them together like that.
Yeah, pretty. Especially when it's colored. Yeah.
Mine's not.
Yeah, that looks cool.
It looks like a snowflake.
It does. First of all, let me just say, I know about this much more than you all know right now about polar coordinates. Okay, and I'm not even lying. Okay? No. You can't, first of all, you cannot manipulate them like you can the horizontal because you don't have enough background. Okay? So you're going to get very frustrated because everything's going to be right here. Okay? You can't, like, wait, I'd like that to move over here. Yeah, I'll do like that. Okay? You can move circles, okay, because you know how to do that. And then you can transform them back if you're really interested, like, say I wanted 2 eyeballs right here and right here. You could do that. Okay?
Yeah, it's probably
Okay?
me.
So you could do the manipulation, but it's going to be a lot of luck when you work on it. It's like, oh, I just tried something, that's bad. Yeah. Okay? So, here, if you want to remember this, on the rows curve, the A is not 0, so it could be positive or negative. Did anybody try a negative, see what happens? Didn't happen. Nothing happens, really. Nothing exciting, right? Let's change, let's turn that off. Let's change this one to a negative.
Let's see what happens. That's the. It doesn't really change. Okay, so the A part doesn't matter. But if theta is even, if you noticed here, this was 6 theta, you should count 12 petals. Okay, but if it's odd, it stays at 5. Isn't that bizarre?
Even doubles.
Even doubles, yes. Okay, you don't have to remember that for anything that I'm going to ask you about. It's just a fun fact. Okay. So add these to your rows column there. A cosine of n theta. If you want to remember that, add it, but it's not anything that I'm going to ask you about. Okay? The positive and the negative doesn't make any bit of difference. Okay? All right, very good. We've got one more, I think, or 2 more. The lemniscate. Meniscus. All right, check this one out. How are we going to put this one in the calculator because it's r squared? You're going to do square roots. You're going to do 2 square roots. One positive and one negative. Okay? So you're going to have to put in both that. Okay? But this is the one that will give it to us as r squared. So that one will be an easy one to pick out that equation. All right, so you're going to do, what do we want, pink and green here? Well, this one is, but yes, it looks like it does, yes. Square root, good question. 4 sine of 2 theta. And we'll do a green one. Negative, square root, 4 sine of 2 theta. All right, there you have your pink and green lemniscates. It didn't do anything if I didn't do the same thing. It went right over the top. What did I do? What did I do wrong then? Okay. All right. The gap might be just a graphical thing. So, but yeah, let me zoom it in and see what happens. Sometimes it leaves a gap just because it just can't get there graphically. Zoom in. Yeah, that's not supposed to be there. So they are the same. Okay. When you're zooming in, it's okay to zoom in because you're keeping it square, but if you start messing with the rectangle, you're going to distort it. Now, that may be what you want to do, but that's not what the lemniscate, to me, looks like an infinity sign. This one really doesn't, but this one does, to me. What does it look like to you? An infinity sign? All right, so that's the lemniscate. And then this is the best one, the spiral. All right. 2 to the power theta over 4. I got it zoomed in, but if you change it back and zoom out again.
Does it always have to be those numbers? Which number can change?
I think anything can change. Just if you have our, I'm going to zoom out again. All right. That's bizarre. That means
Coloring? Yeah, that's just an example.
you know I was spiraling.
It's just, what'd you say?
I tried to zoom in. Clearly, it's not. I tried to zoom out twice. Okay.
No, you gotta wait till it's done.
Usually. By pressing it on. Oh yeah, there it is. Just filling in the whole thing. That's my. Does that look any better? I know it's tiny, 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 tiny. I don't know. Try something, honey. All right, try something. What if have you all tried for spirals? It must be over
Can you
here.
make the denominator bigger?
Okay. I'm gonna change my window back, because I don't like that, maybe it takes too long to load.
You have to put it over something. Yeah. Or it just is.
It's not fun.
Alright. Okay, 2 to the, what, theta over 6? I got both of them going on here now. Oh, yeah, that's a good one. Okay. Daily thing, that's a spiral. You gotta remember the names. Yeah, that's the next piece. Thanks, Melissa. That's the next piece. If you set up your theta, go back to your window here and set theta max to 45. It'll just keep it going and going and going. And that's our. That makes a difference with just your window set. But you'll see why when we grab in my hand why that makes a difference. Now, the spiral of Archimedes says you don't have to have anything over the theta. So if you take just R equals theta, let me get the red one here. The green one's still showing up. There it is.
But yeah, if you like, you know, something great,
Oh,
it's like they go for
I got you.
like we're giving some of it.
Okay.
So like,
All right. Those are the spirals. This is in red. Okay? So you've got this filled out. Spiral. Did anybody try anything other than a 2?
yeah,
It works. Okay. So R equals theta is a spiral. And then R equals some number 2. Now, Emma says, again, I haven't investigated this a lot, but Emma says if you don't have it over something and you just have it to the theta, she doesn't think it's a spiral. Let's check it out. Oh, it is. So A, now that's a spiral, but it's just not a good window for it right now. The green one that. So on that, I'm going to write note here. Theta window. Very important because it makes a huge difference. Whether it looks like a spiral keeps going around or it just looks like whatever that is. It's like one little.
If you do like 2 to the theta over 3, and then do like 2 to the theta over 3 plus 3, 2 to the theta over 3, and 6.
Say it again.
Like instead of, I mean, it takes a lot longer than having and redoing your window, but you can do like the 2 to the theta over 4, and then do like 2 to the theta over 4 plus something else, and it will start at a different place. Like do plus 3, and then just.
Oh, I got you.
Yeah.
So you're just moving it up 3 like a regular transformation.
Well, it moves to the right. It starts 3 to the right.
Yeah. So you've already figured out how to manipulate. If you spend enough time, you can do that, but, you know, who's got that yet? Okay, so anyway, the spiral of Archimedes is this one. Any kind of other spiral is basically R equals some kind of number to a theta power. Okay? I'm probably not going to ask you to identify a spiral equation, but I will ask you to identify any of the above ones from their equation, okay, without a calculator. All right, and I may ask you to know the name with the picture, kind of associate that. So this piece right here, you're just matching up. You throw it in the calculator, oh, that's that one. You don't need to throw it in the calculator, good for you. This one, do without a this exercise, do without a calculator. Okay, tip calculator. Have you all ever heard of a succulent plant?
Yes, I know something about
Oh, okay. Because I heard that on the radio and I was like, I thought succulent was an adjective. I didn't know it was. Okay, thank you, Molly. Yeah, if you want to give me a succulent, see you want one? Oh, sure.
I love it.
They're like cactus without,
They don't have circles, and they're all different.
yeah.
I bet you like the smell of their face.
It's really good. It's certainly a bird. Look for the word align, it was out of smoke and align or jelly.
Wait.
Transform the polar equation to a rectangular coordinate, then correct. You correct it first, that's fine, but.
Because we do like the R side theta one, that's why. We just do white with
Sure.
Oh gosh, I need to turn off this thing here. 50